All right. Hey guys, I am Matjaz. I am a full stack engineer at Zemanta, and today I will talk about deep dive into single page application change detection. More specifically, I will talk about change detection in Angularjs, Angular and React. I choose to include also Angularjs in this talk for one reason only, because I would really like to explain where Angularjs change detection failed. So let's dive in. So what is change detection? Well, change detection is basically something or a component in our application that's basically render the internal state to the document object model. So basically, if we look at the change detection as a black box, this black box as an input, it gets some data structures. For example, objects, array of objects, primitives, and it outputs the DOM representation of this model, of these data structures. And basically, if we look at change detection as a black box, it's really simple. But we have some challenges to tackle. First of all, what if a change in the application happens in runtime? What if we, for example, what if we need to frequently update multiple elements in the document object model? And for example, when the DOM was firstly presented, I think in the 1998 or something like that, well, we didn't actually implement such web applications that frequently updated the DOM with the DOM API. But now with these UI frameworks like React, Angular, and others, we can create really complex web applications that have to frequently update the DOM. And accessing the DOM tree frequently in a large, complex applications becomes really expensive. This is the first problem. The second problem is how can we figure out when the change in our application happened? And the third problem is where do we need to re-render the DOM based on our application state changes? So we don't want to every time re-render everything, but just the parts in the DOM that actually changes. Okay? And JavaScript framework, of course, have different answers to those questions, to those challenges. So let's dive in to Angularjs. Well, in my opinion, Angularjs have no idea what changed. So it will just check everything that may need updating. Okay? So 2 points here. Have no idea what's changed, and he will check everything. Okay? Let's see. So in order to answer what can be changed or what Angularjs can change in the DOM, we need to explain how basically we create Angularjs components, or how we create those bindings between our templates, HTML templates, and our controllers. In Angularjs, we have such syntax. For example, here on the top, we can see that I'm using a header and a span element. And inside of those two HTML elements, I'm putting a binding expression for a scope variable name and email. Okay? Under the hood, Angularjs, for each of those bindings, creates a watcher. And what exactly a watcher is? Well, a watcher is, let's say, a mechanism for tracking the changes of a single scope variable. For instance, for the scope variable name. So he will track what was the value before and after the change. Okay? And if you for example, think of if we have a really big, a really complex Angularjs application, we can have a lot of such watchers. Okay? And what is even more interesting is that for each watcher in our Angularjs application, we can have also multiple watch listeners. Okay? A watch listener is a function that will be called if and only if the watcher is dirty, which means that the value that he is watching changed during the change detection cycle. Okay? And for each of these watch listeners attached to a single watcher, Angularjs will execute that function. Okay? These are basics. Let's move on. On this slide, I wanted to show you the big picture of how the Angularjs application works. Okay, if we start with the part in the Angular context, okay, we can see that we have here this component called digest process. Well, in Angularjs, change detection is called the digest cycle, digest loop, or digest process. Okay, let's suppose that some events, some elements in our Angular context triggered the digest process. So that means that they triggered the change detection. How does it work? In the digest, so this digest process is responsible to go through all the watch lists in our Angularjs application. A watch list is a collection of all the watcher inside a single scope. Okay? And for each of those watch lists, the digest process will go through all the watcher inside it. Okay? It will it will evaluate the watcher, and if the watcher will say, yes, my value has changed, then this digest process will mark this watcher as dirty and will execute all the watch listeners assigned to it. When the digest process comes to an end, it will go once again on the so it will go to the second cycle, and on the second cycle, it will check all the watchers again. So now, if you guys will be here with me, I would ask you why this is the case. So basically, what I was telling you now is that the minimum number of digest cycles that Angularjs performs each time a digest process is executed is twice. Why? Well, I was talking about the watchers and the watch listeners, and basically in the watch listeners, we can also mutate the watch variables. So these are just like, we can say that a watch listeners is a side effect of the watcher, okay? And we can change some variables, some scope variables in the watch listeners, and because of that, Angularjs needs to check those variables again, okay? And this is the main problem here. So the minimum number of digest process is 2, and the maximum is 10 times. So Angularjs allows us to so it can allow the digest process to check for changes 10 times in a single process, okay? And after 10 times, Angularjs will throw an exception, because he will figure out that, okay, if I didn't evaluate the true value of a variable 10 times, in 10 times, then something is going wrong, okay? And after what is now also important is that after the digest process is done, the digest process will tell Angularjs, so we will output all the instructions to Angularjs how to update the DOM, okay? And then Angularjs, based on those instructions, will re-render the DOM. In our browser, we have certain, let's say, events, browser events, like on clicks or set timeout functions, or fetch requests and other stuff. But all those, let's say, events, all those functions, these asynchronous functions, triggers, can trigger some, or can update, can change the state of our application. But as you can see, all those events, well, basically they call a callback function in the JavaScript scope, not in the Angularjs context as well. So if we want that our Angularjs application is aware of some changes during the runtime, right, we need to use certain Angularjs specific components, like the ngClick, okay? For example, for Ajax with callbacks, we use $HTTP client. For example, instead of set timeout, we can use $timeout, etc. Also, we have the capability to manually invoke the change detection cycle with the $apply function. Okay? So, and with all this knowledge now, we can answer the question, how can we break Angularjs application? Well, it's really simple actually. We just create a single watch listener. This is basically a watch listener. So let's suppose that in our scope we have a variable A, okay? And this variable A has a binding in our template. So this variable A will have a watcher. And also we will create a watch listener, and every time the watcher will be dirty, this function will be executed, okay? And what are we doing? We are mutating the scope variable A every time, okay? And now with the knowledge of the digest cycle, we can really quickly see that this watch listener will be executed, or because of this watch listener, the digest process will be executed 10 times, and Angularjs will throw an error, an exception for us, and we are done. Okay, let's move on. Angular. Well, in my opinion, Angular knows exactly when to check for changes and know exactly what should be re-rendered. Okay, so exactly when and what. Let's see. So when to check for changes, right? Or the most interesting question is what causes change in our web application? Well, they figured out that all asynchronous calls can change a state in our applications. So each events like click, submit, scrolls, each fetching data, each fetching data from a remote server, every timers, set intervals, so everything. So everything that is asynchronous can make changes. Okay, so they figured out that, and based on this knowledge, they implemented, or they used a solution which is called zones. So there is a JS library called Zone.js, right? Which is basically an execution context for asynchronous operations. And what does that mean is that it can perform an operation, okay, each time some code enters or exits a zone. So basically, we know if we use zones in our application, for each asynchronous call, we can execute this asynchronous call inside a zone, and zone will provide to us the capability to execute some code whenever this asynchronous call will be evaluated. Okay? So let's see an example. Suppose that we have three synchronous functions in our JavaScript code, x, y, and z, okay? And we want to measure the time, the total time of execution of those three functions, okay? I said that those three functions are synchronous ones. So basically, this is the code that will measure the time. So at the end, we will print the total time of execution. But what now? What if we put the epsilon function inside a set timeout? What now? So if we think more specifically how the JavaScript runtime actually works, and if we look closely at the call stack of the JavaScript runtime, well, first of all, let's suppose the start date.now will be put on the stack, okay, on the call stack of the JavaScript runtime. It will be executed, okay, and the stack will be cleared. Then X will be put on the stack, it will be executed, and it will be cleared. Then set timeout will be put on the stack, and it will be then somehow removed from the stack, okay? Then Z will go to the stack, it will be executed, time will be put on the stack, console.log will print the time, and then the epsilon callback will be eventually put on the stack and executed. So basically now we know that this time here will not be equal to this time here, even if we use the set timeout and we said, okay, 0 is the timeout. So basically we are telling with this function here that we want to execute the callback as soon as possible, okay? So let's move on. So how can we assure that we can measure the total time also of these asynchronous calls? Let's assume that we include zones in our applications, okay? And then we create this function main. We put those three functions before in this function main. So X, set timeout, Y, and Z. And we call zone.run on this function main. What we will see or what we will get is we will basically this zone.run will create two zones, okay? The first zone will encapsulate all the synchronous calls, okay? And the second zone will encapsulate all the asynchronous calls, okay? But how is this possible? We created a single zone and we put all those functions in this zone. Well, the answer is that guys from zone basically monkey patched all the asynchronous browser operations like set timeout, set interval, alert prompt, add event listeners, and who knows what. And every time we include zone in our application and we use some of those asynchronous calls, well, this will result into zone.setTimeout, which will fork the previous zone and execute the callback inside a new zone, okay? But wow, nice. But how does this help us? Well, basically, as I said, each zone can provide the capability to execute the task before and after the code leaves the zone. And this is the pseudocode or the algorithm which can provide to us the capability to measure the time. So we can see we are now, let's say, forking the global zone, and we are putting, so whenever we fork a zone, we can provide some configuration to it, okay? And the configuration for our zone will be that before we enter the zone, we will create a timer, so date.now, right? And after so when we leave the zone, we will just increment, or we will just increment the time by the date.now minus the before start, okay? And also we are adding some extra time function which will just return this time. Okay? And also we are again forking the profiling zone just for the example, and we are extending the after task. You see the after task callback with a new function, and we are just outputting in the console the time that took this zone to complete. And we put the main function in this our newly created zone. Okay, so basically the output will be, for the first zone it took some time, and for the next zone it took some time, and the output of the second zone, of this asynchronous zone will be the total time. Cool. So now we know what are zones and why are they used for, but how is this even connected with Angular? Well, basically, Angular used zones in order to attach itself to these events that are triggered every time our event queue is empty. So now maybe a few words how this JavaScript runtime event loop works. So basically, I said that we used set timeout. This set timeout is put on the call stack, then it is redirected to the web APIs. The browser is executing the timeout, and when it is done, it will put the callback on the event loop, right? On the event queue. And then the event loop kicks in, and each time the event loop checks if the call stack is empty. If it is, it will put the first item, the first event in the event queue to the call stack, and the JavaScript runtime will execute this. And each time the event queue is empty, it is the time that Angular can check for changes, because some asynchronous operation completed, and that's the time when Angular kicks in and check for changes. How this is done? Well, in Angular we have this application ref class, which is basically a reference to our running Angular application. Okay. In the constructor we include ngZone. Okay. And what are they doing? They are subscribing to this on microtask empty, which is basically the logic behind it is the one that I told you right now. And each time, let's say, an asynchronous operation completes, this function here will call the tick method, which basically performs change detection. So it will run, it will iterate on all the views, okay, that are provided into this application ref. Basically, this application ref in most cases will contain this arrays of views, will contain just one view, and this is our root app component. Okay, and on this component it will execute detect changes, which will basically then propagate this change detection through all the components in our application. Okay, let's move on. So this was when AngularJS can check for changes, and now what to re-render. Okay, so this picture seems very likely to AngularJS. Okay, so we still have those template bindings, let's say, but here we can see that the arrow goes from the model to the DOM. Okay, so basically in Angular, each template, each HTML template that we create will be during compilation compilation compiled into some TypeScript code. Okay, and this TypeScript code is then responsible for creating the DOM. And inside this TypeScript code, this factory, okay, we have also those bindings. So every time change detection runs, like I showed you before, in this factory, we just check for these bindings, okay, that are defined in our component. And if these bindings changed during change detection, the Angular will just refresh the state of the template. So just the dynamic part, not the static one. We can talk about that a little bit later. So let's move on. I told you earlier that whenever the event on microtask empty is triggered, okay, Angular will execute the tick method on the root component, okay? Basically, I didn't tell you that Angular application is a tree of components, okay? Each component has its own change detector. So basically, we have a tree of change detectors, okay? And change detection starts always on the top, on the root of the tree. It runs change detector on the root component, and then this propagates to the leaves. So this is the default behavior of change detection in Angular. So whenever an asynchronous operation is executed, like a click, a scroll, a submit, a set timeout, etc., Angular is smart enough to perform change detection. And by default, it will run change detection over the whole tree. But what is very important here, is that change detection will run exactly once to all the tree of change detectors. So we can see that here is a big improvement over AngularJS, because AngularJS will run at minimum twice, at maximum 10 times for each change detection cycle, where Angular will run exactly once. But with Angular, we can be even more smart and even more performant. So in JavaScript, objects are mutable by default. So let's suppose that we have an object representing a user. For example, this object has a property username and, I don't know, email or something, right? And let's suppose that this component here is the one responsible for rendering the state of the user. The first time that we create the instance of the user, okay, the change detection, okay, will basically see that this user was changed, okay, and he will run change detection on this component and will eventually re-render the template. But what, for example, if some click was executed in this component here, which is not even connected to our user component? Change detection will run again. And because Angular doesn't know that we didn't change the user, right? Because the reference to the user object stays the same, he will run change detection again, also on the user component. But if we tell Angular that we are dealing with immutable objects, okay? So immutable objects means that whenever we would like to manipulate the state of an object, we need to create a new instance of it. So let's see now again this picture. Suppose that in this component here, we triggered some click event, for example. Change detection will run, and it will see that the user input reference stayed the same because we didn't change the user. And we also tell Angular that we are dealing with immutable objects. Based on this knowledge, Angular will not execute change detection over this component. And also this means that this change detection will not run also on the other childs of this component here. So basically, we will skip the whole subtree of change detectors. So this is really easy to establish. We just enable the change detection strategy on push on each component. And well, we need to take care that we are dealing with immutable objects. But we can be even more performant. So let's assume that in this component here on the bottom, we have some extra logic. Let's say that we are fetching a remote server, a remote API, every couple of minutes. And we want that the payload, the result of the fetching, is resulted in some part of our web application, so basically in the template of this component. But we don't want that every couple of minutes, because we change something here, the change detection will go through all the components and check for changes. But we want that change detection is smart and just check for changes in this component more specifically, every couple of minutes. What we can do? Well, basically, Angular provides to us the capability to inject an instance of the change detector ref, because we said that each component has a change detector, and we can now get an instance to it. Okay? Furthermore, we can exclude this component from being observed by the change detection cycle. So we can say to this change detector ref that we don't want to be included in the change detection cycle anymore. But only after the fetching is resolved, we can use the change detector ref and set mark for check, which will mark the path from our component to the root component. And next time the change detection cycle will run, it will see the marked path, and it will go just on this marked path and will check for changes on those components. So we skip basically everything that is not somehow related to our component. Cool. And now React. In React, I will not talk about pure components or stateless component. I will talk about a default React component. And if we assume that React basically does not have an idea what's changed, like Angular does, okay? So it will just re-render everything and see what's different now, okay? Let's see. So if we are talking about React and change detection, we encounter something called the virtual DOM, okay? And before we really dive into the virtual DOM, we need to just, let's say, make some ground rules or make some basics. So what is a DOM? First of all, well, basically it's an object-based representation of the HTML, plus it provides a DOM API, which we can use to manipulate the DOM, okay? So here is the HTML, for example, of an unordered list, okay? And this is basically the DOM. Let's suppose it's an object-based representation of this HTML, okay? So, and now we can use the DOM API. So what we want to do is, for example, change the list item to be list item 1. So the text of the list item we want to change to list item 1, okay? And we want to add an extra list item as well, which will be list item 2, okay? So how can we do this with a regular DOM API usage? So for example, we can use this getElement by class name, okay? We get the first item of it, we change the text content to list item 1. Then we get an instance to the list, okay? We create a new list item, we populate all the metadata on this list item 2, and then we are appending list item 2 to the list, and we are done. Okay? But as I said in the beginning of the presentation of the talk, when we need to frequently make such operations on a large scale, those document API operations, for example, get element by class name, etc., can become really slow. So basically, we need to manipulate the DOM in a more performant way. Okay, and this is where virtual DOM kicks in. So basically, virtual DOM is not an official specification, it's just a new method of interfacing with the DOM. Basically, is a JavaScript object which is representing the DOM. It's a copy, basically, of the original DOM. Okay? And if we are dealing now with JavaScript objects instead of the real DOM, we can do like a lot of frequent frequent operations over these JavaScript objects, right? Without using the DOM APIs. And basically, we are not, let's say, we are still very performant. Okay? And this idea is the idea behind the virtual DOM. So let's now create the virtual DOM ourselves. So, for example, this is a JavaScript object representing the list item that we saw before. So, for example, we have the tag name, an ordered list, we have some attributes, okay, and then an array of childrens. So for now, the children are just the list item, and that's it, okay? Now what we do, we will copy this instance, okay? We will change the text of the first item inside the list, okay? And we will add a new item to the children's of the unordered list, okay? And we can be really efficient because we are just dealing with regular JavaScript objects, okay? Now, what we will do, we will create some diffing algorithm, okay? And this diffing algorithm, let's suppose that it is a black box to us, and it will output something like that. So for each item in our children, in our list, okay, for the first item, because was already it already exists in the original JavaScript object, okay, we will have a new node, which is a new version of the list item 1, the old node, the previous state of this, and the index where this element was placed in the children's array of the list, okay? And then we will have also a new object which will have just the new node and the index, okay? And then we have this logic of applying the diffs, which can go something like this. So for example, we query the list item, okay, from the real DOM, and then for each diff in our diffs, computed the diffs, we are basically always creating a new element, okay? And we are checking if the diff contains the old node, then we are just replacing it, otherwise we are appending it. And this is somehow the virtual DOM basically works, okay? Well, in React is just, let's say, a UI framework that uses the virtual DOM, and they implemented the diffing algorithm and the applying of these changes thereon. But the idea behind it, it's pretty much the same. So now some additional inputs on React. We said that we know that React doesn't use bindings, okay? Like we use them in Angularjs or in Angular. The core part of the change detection is the virtual DOM comparison, like I described in these previous couple of slides. And basically, each React component needs to implement this method render, which will return a JSX template. Okay? And if we inspect in detail this return statement, basically what we do is that for each, let's say, element inside this return statement, so we have a return statement that returns a template of the list item, for example. For each item, React will create under the hood a virtual DOM node, okay? And when it merges this virtual DOM nodes together, it creates a virtual DOM tree, which is basically that JavaScript object that I was talking about before, okay? And the result of this render is a virtual DOM tree that is then passed to React. React then checks if the previous virtual DOM tree differs from the actual DOM tree. If it does, it will smartly calculate it will smartly output all the instructions that needs to be applied on the real DOM in order to properly patch the real DOM, okay? And basically, this is somehow described in this picture. So, as we can see, we have our model, and each time we call the render method, we create a virtual DOM representation of that model, okay? And we have a previous and the current version of it. Those two versions are then inputs to the diffing algorithm, which is smart, and it will output just the instructions to properly patch the real DOM. And that's it. This is how React works. And just to summarize, before I said that React doesn't know when to check for changes, and this is also true. Why? Because we always need to manually, just a bit lag, okay? We need to manually initialize the process of such change detection, for example, by calling the setState method inside our React component. Okay, that's pretty much it. And so the last slide is just which one UI framework will you choose? Well, of course, try to not choose AngularJS. Thanks.